Alright gang, welcome back to a new week. Hopefully your Memorial Day weekend was quite lovely. We're gonna get into section 6-5, which is called Solving Square Root and Other Radical Equations. So, as we often do in a lot of math chapters, when we're learning about a new type of function or a new type of thing, there might be a section where you put that new gimmick, that new type of function, that new thing, in the context of actually solving an equation for x. So you'll see what I mean clearly enough in a minute or whatever. So what's this first note here? For an equation to be a radical equation, it needs to have a variable in a radicand, so there's got to be like the radical symbol, the square root symbol or whatever, and it's going to involve a variable, or have a variable with a rational exponent, because remember, radicals imply roots, and so do rational exponents. In other words, a fraction as an exponent. If you see like x to the 1/3 power, that involves roots, and that would be like technically a radical equation, and those are the type of equations we're going to be solving. So like literally, like you've been doing for years, we're going to be solving for x, and you don't need to write this down. I'll just kind of give you like a lot of perspective. I probably don't need to go too deep into the whole like thing of back in like 7th grade or whatever, you were just solving equations like this, where you were just trying to get x by itself, trying to figure out what x would be able to equal. And especially when the equation got really complicated, you would do like the opposite of whatever was crowding the x, like in order to get x by itself, we would have to get that +2 out of there by doing the opposite of adding 2, which was subtracting 2. So you would subtract 2 from both sides. You are allowed to do that. You're allowed to subtract 2 as long as you do it from both sides of the equation. So likewise, here, in order to ultimately, at the end of the day, get x by itself, we're going to have to do like the opposite of this whole big square root. Okay, but we're not going to do that until we get rid of this 2. So what we're going to do first is get the entire square root chunk by itself. Okay, so once again, at the risk of repeating myself needlessly, ultimately, at some point anyway, we're going to deal with this whole big square root and do the opposite of the square root. But before we do that, we got to get like the square root chunk by itself. And as long as this 2 is over here, the square root part is not by itself. So the first thing we're going to do here is subtract 2 from both sides, and that gets that 2 out of there, and the right side becomes a 4, and now what we have is the square root of 3x minus 2. Now comes the time to see how this square root is over this whole thing, right? So I'm not going to move that -2 out of here. I'm not going to worry about the 3. The next thing I'm going to worry about is this square root, and again, this square root is over top of all of it. So I can't deal with anything until I undo this square root. Okay, now here comes one of the biggest questions of the whole lesson. How do we do that? How do we get rid of a square root? What's the opposite, per se, to taking a square root. What would like cancel out a square root? Well, we're going to square both sides. Whoa. Yeah, you can do that. Just like you're allowed to, like up here, just like you're allowed to subtract 2 from both sides. Oh my gosh, same thing here. That was kind of weird. I didn't even plan that. But you can subtract 2 from both sides. You can add 10 to both sides. You can divide both sides by 5. You know, there's all kinds of stuff you can do to both sides. We've seen in this class. You can take the square root of both sides. Well, you're allowed to square both sides. Now, like I've been hinting at, squaring the left side, all that's going to do is cancel out the square root. So again, just cancels out the square root, and what you're left with is 3x minus 2. But when you square the right side, you get 16. And now look how nice that is now. Again, you've been solving these things since, I don't know, 7th grade, 8th grade, I don't know, maybe even 6th grade. But now you can just solve this easy peasy by what? Adding 2 to both sides and then dividing both sides by 3 like you've done 100 times in your life. So, quick recap. The big time move we do in these brand new equations like this is at some point square both sides to undo the square root. But in this situation, we first had to move this 2 away from the left side. Okay, so you got to isolate the square root chunk and then square both sides, and what you end up with is very easily solved. Alright, now we get a little nastier. We have the 2, and then we have this bubble to the 2/3 power. Since this exponent is a fraction, technically this means, you know, we have a root. We have a third root. So we're taking like the third root, not the square, like this was the square root. Okay? This is technically the third root, but since that is a 2 in the numerator, we're also technically squaring that x minus 2. So the 2 is a power and the 3 is a root. So imagine, you know, this x minus 2 had a radical symbol around it, except it represented like a third root, but we were also squaring it. Crazy. Now I hope you sort of believe me, you know, and you kind of see quickly that the first thing we're going to do is get this 2 out of that side, like away from there, by dividing both sides by 2. Okay? So that's the first thing we do. Before we go to undo any roots or undo any powers or crazy exponents, we first isolate that part, okay, which means get that 2 out of there. So the right side becomes 25. So now the next part is we're going to try to undo this 2/3 power. And you could look at it as we have to, it's like a two-part sort of plan where we have to undo a third root, but we also have to undo a second power. That's interesting. So what it says here, now take the square root of both sides. So it looks like I'm taking like a two-part approach, like a two-step approach. I'm going to get that power of 2 out of there, and then after that it looks like I'm going to deal with the third root. But again, overall we have to like undo this whole 2/3 power to free up the x minus 2, and so we can actually solve for x. So again, now take the square root of both sides. That's going to get rid of the power of 2. Oopsies. Now, plot twist. You guys got to remember that when you take the square root of both sides, technically you need to have, well, maybe too soon there. I know it's too late, but I'll just cover it back up for a second. As I was saying, when you take the square root of both sides, you get a positive answer over here or a negative answer. It's just like back when, and you don't need to write this down again. X squared equals, I don't know, I don't want to go with the same old, like 16, or let's go with 9. So remember, solving this, and you take the square root of both sides, you get two answers. Positive 3, or in another answer, separate answer is negative 3. Same thing here. We took the square root of both sides, and we get two of these. And now, you see how now the power is just 1/3 because we undid. So now we got to undo like a third root. And what's the opposite of a third root? Well, it's the third power. So that's what this means. Now cube both sides. In other words, now raise both sides to the third power to cancel out like this 1/3 power, right? I mean, it's third root. And so when you take the third, when you raise both sides to the third power, that's just going to cancel out the 1/3. So on the left side, you just end up with x minus 2. But on the right side, when you raise that to the third power, you get 125. And over here, you get negative 125. And then you just have to, like, now that this x minus 2 has been freed up, now you just got to add 2 to both sides to finish off getting x all by itself. So remember, 125 plus 2 is 127. Negative 125 plus 2 is actually negative 123. So keep this situation in mind, okay? Basically, remember how when you take the third root, second root. When you take the square root, second root, square root of both sides, you have this positive case and also a negative case. One more example where we get a little bit, I don't want to say crazy, but it's like another little plot twist. So check this out. Check for extraneous solutions. Well, what word, of course I'm on the color of white. What the? I want you to like notice how like this root word here in extraneous is extra, Check for extra solutions that we use that, and by extra solution, it's like it's not really a solution, We got a solution that's like not even really a solution. And that can happen sometimes, and this is just one of those situations where you end up like squaring both sides. Eventually we got to square both sides, but the other side has its own like variable. So compare it with here, where like we were squaring both sides, but there was no x variable over here. But when you have an x variable on the other side, that's where you end up with like, extra non-solutions. So we'll check for that at the end, but first we're going to solve this and stuff. So what do you think? Do you think we can square both sides right away? No, because the square root part is not isolated on the left side. That plus 5 needs to be moved to the other side first. So we do that, and we do by doing the opposite. So we subtract 5 from both sides, and then we get 2 here. Okay, and now that this square root chunk is all by itself, now we do the opposite of a square root. We square both sides. Now again, like I've said already a couple times, squaring this is only going to cancel out the square root. So you're just left with x minus 3. Squaring this, okay, involves FOIL, right? I mean, think about it. X minus 5 times x minus 5. We do like all the FOIL, and you get this, which reduces, well, simplifies. Like these terms combine, so these two terms combine, and then what ends up happening, you know, like yada, 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 in order to solve this, think about it. If I gave you this and said solve it, you know, you'd end up realizing that you'd have to set it equal to 0 and try to like factor. So these two terms combine, and then you move this term over there by subtracting it, and so minus 10x becomes minus 11x when you move that term over here. And you can probably see how the plus 25 became a plus 28 when we move that term by adding 3 to the other side. And again, in order to solve this quadratic equation, we have to like set it equal to 0. And now we hope and pray that we're not going to need the quadratic formula. We hope that this can factor. So can it factor? First we check for a GCF. There ain't one. And so we hope that this unfoils. Okay, if this unfoils, like it wouldn't need Phoenix method, this will unfoil as long as there's two numbers that multiply to get positive 28, but they also add up to negative 11. Ooh, negative 4 and negative 7. And then, you know the drill, right? After you factor, you would set both factors equal to 0 and then solve. But remember, we just spent a lot of time in like chapter 5, I think it was, where it's like, if these are the two factors, then your answers are going to be just positive 7 or positive 4. Okay? So these are two possible answers by doing all the by going through the drill, okay? But remember, checking for extraneous solutions. One of these solutions might not actually be a solution. Here's how we check. We just throw these back into the original problem. Let's check x equals 7, okay? So what if x was actually equal to 7? 7. Does this play out? Okay. So 7 minus 3 is 4. Okay. The square root of 4 is 2. 2 plus 5 is 7. Okay, so you're good. You're good. Now let's try... Let's see if x could equal 4. Let's see. 4 minus 3 is 1. The square root of that 1 is 1. 1 plus 5 is not equal to 4. Oh, so it turns out that x equals 4 was extraneous, which means it's not really a solution after all, which again can happen when we square like something involving the variable. But anyway, I think that covers all the different situations, you know, like undoing a fraction as a power, just undoing a square root, and undoing a square root where you might have to check for extraneous solutions, okay?